This lecture is about the principle of conversion of solar radiation into heat. How solar energy can be converted into heat. How we can extract thermal energy or heat from the solar radiation. So the basic principle behind this heat conversion process is the greenhouse effect. So all of us are familiar with this term, greenhouse effect. So the basic principle used for converting solar radiation into heat is the greenhouse effect. So we know that among the radiation that is coming from the sun towards the earth, a part of the radiation is reflected back by the earth and the atmosphere, and the remaining radiation is absorbed by the earth's surface. So when the surface of the earth absorbs this radiation, the earth warms, the temperature of the earth increases. So when a body receives solar radiation, it is having a tendency to re-emit infrared radiation. So when our earth receives this solar radiation, earth surface will re-emit infrared radiations. So we know that infrared radiations are heat radiations. So infrared rays are characterized by their heat energy. So they are actually heat radiations. So earth surface re-emits heat radiation, and a part of this heat radiation re-emitted by the earth surface will be trapped or absorbed by the greenhouse gases present in the atmosphere. So a part of the infrared waves, infrared rays emitted by the earth's surface will be absorbed by the greenhouse gases present in the atmosphere, and the remaining passes through the atmosphere. Remaining part of the infrared radiation passes through the atmosphere and it is lost. And the greenhouse gases like carbon dioxide, methane, etc. present in the atmosphere absorbs this infrared radiation, and it re-emits radiation back to the earth. So as this infrared radiations are heat radiations, so this process helps to maintain a temperature on the earth's surface which is suitable for maintaining life in the earth. So the temperature required for maintaining or sustaining life in the earth is retained by this particular process. So this entire process can be pictorially represented like this. So it can be divided into 6 steps. So in the initial step, the radiation from the sun falls onto the earth's surface. A part of this radiation is reflected from the earth's surface, and remaining is absorbed by the land and the ocean. Thus earth gets heated, and as a result heat radiates some of the energy. The heat radiates infrared radiations, and a part is lost to the atmosphere, and some of this heat is trapped by the greenhouse gases. A part of the infrared radiation is lost to the atmosphere, and remaining is absorbed by the greenhouse gases present in the atmosphere, and they re-emits these gases into the earth. And due to the processes like burning of fossil fuels, agriculture and land clearing, etc., the amount of greenhouse gases in the atmosphere increases. And as a result of this, as the greenhouse gases increases, the infrared radiation will be more and more absorbed by them. More infrared radiation will be absorbed by these greenhouse gases, and they will emit these infrared radiation to the earth. This leads to an increased amount of temperature on the earth's surface, and a very noticeable increase in the temperature, and this phenomena is known as global warming. So global warming is a disadvantage. So the entire step in the principle of conversion of solar radiation into heat we have seen. So we can simply draw the diagram like this, the principle of conversion of solar radiation into heat. The diagram can be schematically drawn like this. the incoming solar radiation hits the Earth's surface. Some will be reflected, some will be absorbed by the Earth's surface, and the Earth then emits infrared radiation, and thus that radiation will be absorbed by CO2 and other greenhouse gases in the atmosphere, and it re-emits a part of the radiation back to the Earth, thus maintains a required temperature on the Earth. So in the initial part we have said that the basic principle behind this heat conversion process is the greenhouse effect. Now, why this is called as greenhouse effect? Why we are saying that the basic principle is greenhouse effect? How this phenomena has got that name, greenhouse effect? Let us see. So what are actually greenhouses? Greenhouses are structures made up of transparent materials, usually glass, for grow exotic plants in cold climates. So exotic plants means plants which are brought from some other countries. Plants which are brought into a particular country from other countries. So that means these plants may not be able to grow in our climate. It needs a certain favorable condition for its growth. So if we are considering countries with cold climate, there may be some plants that requires a particular amount of temperature for their growth. So in that cases, those plants will be placed in a greenhouse which is made up of transparent glass. So we know that this glass is transparent to the incoming solar radiation. So it easily passes the incoming solar radiation, and when this solar radiation hits the object inside this glass house, this greenhouse, infrared radiation will be emitted from those objects. നമുക്കറിയാം ഏതൊരു ഒബ്ജക്റ്റിൻ്റെ പുറത്തും solar radiation fall ചെയ്ത് കഴിഞ്ഞാൽ that object will re-emit infrared radiation as heat. So from the objects inside this greenhouse, the infrared radiation will be re-emitted, and it will be a long wave radiation. That infrared radiation will be having a long wavelength, and glass will be opaque to infrared radiation. Glass will not allow infrared radiation to pass through it. So this glass will act as a heat trap. So heat cannot escape from this glass house, thus maintaining the suitable temperature required for this plants. So this is the basic principle of a greenhouse, and as this principle of heat conversion is used in greenhouses, it has got the general name greenhouse effect. So now the same principle is used in the solar thermal energy collectors. There are some devices known as solar energy collectors used for collecting heat energy from the solar radiation. Those devices also works on the same principle. So they will be having a glass cover on their top. So this glass cover will allow solar radiation to pass through it, and below that glass cover there will be a black color coated absorber which is for absorbing the solar radiation. So when this solar radiation falls on this absorber, the absorber will re-emit infrared radiation, and this glass will not allow infrared radiation to escape from the device. So the temperature of the absorber increases again and again. This is the principle used in solar thermal energy collecting devices. Okay, so as more and more solar radiation comes, the heat energy of the absorber increases, and as a result the infrared emission from the absorber also increases. So എന്താണ് നമ്മൾ പറഞ്ഞത്? Solar energy collecting devices ഉണ്ട്, known as solar collectors. So they will be having a glass cover on the top. It allows solar radiation to fall onto an absorber coated with black color. So this absorber absorbs the entire solar radiation and its temperature increases. And this absorber will emit infrared radiation, but the glass will not allow the infrared radiation to escape from this device. So the temperature of the absorber increases more and more, and as a result, infrared emission also increases. So emission increases with temperature. So this curve shows the plot of emittance from the absorber with respect to wavelength, and we can see that with increase in temperature, what happens? The emission also increases. So as temperature increases, the emission from the absorber also increases, and the re-emitted light will have shorter wavelength and greater energy as the temperature of the surface increases. So അങ്ങനെ സോളാർ റേഡിയേഷനെ അബ്സോർബ് ചെയ്ത് അബ്സോർബറിൻ്റെ ടെമ്പറേച്ചർ കൂടുന്നതനുസരിച്ച് അബ്സോർബറിൽ നിന്നുള്ള ഇൻഫ്രാറെഡ് എമിഷൻ കൂടും. പക്ഷേ പിന്നീട് വരുന്ന ഇൻഫ്രാറെഡ് റേസിൻ്റെ വേവ് ലെങ്ത് കുറഞ്ഞു വരും. സോ വി ക്യാൻ സീ ഇറ്റ് ഫ്രം ദിസ് ഗ്രാഫ്. So with increase in temperature, emission is increasing, but the wavelength, see, the wavelength at emission is maximum is decreasing. So this, for this temperature, this much is the wavelength, and as temperature decreases, wavelength is more. Okay, so with increase in temperature, the wavelength at which maximum emission occurs decreases. So according to Wien's law, lambda max into temperature is equal to a constant. So lambda max means the wavelength. Lambda max is the wavelength corresponding to maximum emission. So from this diagram, from this equation, we can write it as lambda max is inversely proportional to T. Lambda max proportional to 1 by T. So lambda max is inversely proportional to T. That is, as temperature increases, lambda max decreases. Just shown here. With the increase in temperature, the wavelength at maximum emission occurs decreases. So this is all about the principle of conversion of solar radiation into heat.